from S to T, the access control system would check, first of all, that the administrative subject owns this object. And if that is the case, and if S already has the read access, then it deletes it from that entry and transfers it to the other one. So if you have this configuration of the matrix and A attempted to transfer this access right, it would succeed, and you'd end up with this new configuration. So this is all trivial. This is all really, really boring, and you should all be familiar with this. Just as an aside, if you start having administrative capabilities in a model, you are heading for problems. So you want systems which have administrative flexibility. You want systems where you can reason about security and preservation of security properties. But if you do allow changes to the configuration of even simple models and even simple changes, you will then end up with considerable difficulty analysing the security properties, how this configuration may evolve. And Harrison, Rutzer and Ullman and other people studied the protection matrix quite extensively in the late 70s. Since then, there have been a variety of different models proposed and analyses of the safety problem in those models. And typically, it's difficult, often undecidable, very often, if it's not undecidable, it's intractable. So that's really sort of an aside. But the point is that if you have administration, unless you constrain it in certain ways, it becomes difficult to anticipate how your system will evolve. So again, just a small amount of revision. Role-based access control, I believe most of you will be somewhat familiar with this idea. It was basically introduced to alleviate administrative burden, in fact, rather than having to deal with this huge access control matrix or even access control lists. You would have these sort of placeholders called roles to which you would assign users, and you would also assign users permissions, access rights, if you like, to these roles. So the idea was that, or the intuition was that the number of roles would be significantly less than either the number of users or the number of access rights or permissions that were involved. And this was confirmed by a study when a large German bank, Dresdner Bank, did indeed implement a role-based system and found that it was a fraction of the number of users, the number of roles that was required. So there is empirical evidence to suggest that role-based access control is not a bad thing in terms of alleviating the amount of work you have to do in maintaining access control data structures. So what is it? Well, this is a description of RBAC 96 due to Ravi Sandhu. I mean, other people, David Fariolo, who I think spoke here last year, and a number of other people, were all having the same sort of ideas at around the same time. Ravi Sandhu probably just wrote it down better, but somehow this model is the one that's stuck and has been the foundation for the NIST standard, which came out earlier this year on RBAC. So you have a partially ordered set of roles, which models a role hierarchy. This in turn is supposed to represent in some way the roles, the functions within the organisation. So you might have a role like cashier or finance clerk or finance administrator. And you would organise these roles in a hierarchy to reflect the enterprise hierarchy and the seniority within that enterprise. You have a set of users, you have a set of permissions. I'm not going to dwell on what permissions are. They're slightly mysterious. The literature tends to say we treat them as uninterpreted symbols because they don't want to be specific about the application that role-based access control might be used for. So we have these permissions which somehow allow users to do things, but we won't worry quite what the internal structure of these permissions are. You have a user role assignment relation which associates users with roles, and similarly you have a permission role assignment relation which associates permissions with roles. So as I've said, role hierarchies are there to reflect the enterprise structure, And it's also been claimed that they can facilitate or simplify. Well, it's a slightly tenuous claim. They say that this helps the separation of duty constraints. It merely just, it becomes obvious from the hierarchy what things perhaps ought to be in separation of duty. But that's a whole different story. But one of the main reasons for having role hierarchies is that it further reduces the number of assignments you have to make, because you have this idea of implicit assignment. If you've got, well, there's an example on the next slide. So this is the theory. I'll show you a picture which will hopefully make it clear what's going on. So this is a typical role hierarchy. If you've read any of the literature, you will recognize this picture. This is taken from one of Ravi Sandhu's papers, and it represents some kind of enterprise, and you have two different projects. You have a project leader, one, a project engineer, a quality engineer, and an engineer associated on one side of this hierarchy, and you can imagine this is subscript this with a 2 on the other side perhaps. So what's going on? If I'm assigned to PL1, then I can access all the roles below that in the hierarchy. So I'm somehow implicitly assigned to all these roles. If a permission P is assigned to, say, QE1, Quality Engineer 1, then that permission percolates up the hierarchy and is available to all senior roles. So the sort of punchline is that I can use this permission. All right? If someone, say, Kenny, a colleague of mine, was assigned to Production Engineer 1, then he wouldn't be able to use this permission P, because Project Engineer 1 isn't included in this upper region above QE1. So, it's all too late. I'm already struggling for time. So, role-based administration. What are the dynamic components? Remember I said when we looked at the protection matrix, we need to identify what we may need to change, and then we need to think about how we're going to control those changes. So we have a set of roles and a partial order. That's the role hierarchy. We have a user role assignment relation, and we have a permission role assignment relation. Okay, so what will we need to do? Well, for each of these things, we may need to add or delete things. So we may need to change the role hierarchy by adding or deleting an edge. We may want to change the underlying set of roles in the hierarchy. We may need to change user role assignments, and we may need to change permission role assignments. Fairly straightforward. But this kind of thought experiment, so it's perhaps too grandiose a term for it, is worth doing. You know, it's worth saying, what have I got in my model, and what do I need to change, and how will those things change? So this is the hard slide in the talk, and you can sort of shut your eyes and hope it goes away, which it will in a minute. This is the formal definition of administrative scope, and this is the building block for all the role-based administrative models that I've developed. I'm not going to try and explain it. If you take this away and it's available on the web, you can go away and think about it. This is a much more accessible slide. So what is it? All right. So the idea is that the administrative scope is a set of roles which, if you make changes to them, it's only felt locally in some way. And if a role is in the administrative scope of an administrative role A, then all roles greater than or equal to that role are in some sense bounded by A. When you see a picture, this will become clear. But I'm claiming that this is a natural unit of administration for this role A. So if we go back to this picture and we look at the administrative scope of PL1, it goes like this. I'm going to show you a role which isn't in the administrative scope of PL1 first. So let's take this role here, EMP. And if you look at the roles above EMP,